Hi everyone, welcome to the 5th video in the solution series for the Brickfield Computer Programming Challenge of 2017. In this video we'll be looking at the Negligent Norbert problem, which was a pretty tough problem. Only a couple teams were able to get this one, and we just did one last time. So yep, so this is around. Okay, so in this problem we have to. There's a guy named Norbert, and he is answering clarification requests to a programming competition. So instead of actually answering the requests, because he's lazy, he's just going to give the shortest answer possible to each request, so that each of his requests, or each of his answers are unique. He has Q request to answer, and he's using language with n characters, and then we have a bunch of test cases. I don't know if I mentioned it in the problem, but each test case is independent, so he can give the same response in 2 different competitions, just not the same response twice in the same competition. Alright, so one thing to go over before we start actually programming is that let's say for 3-letter words, if you're having 1 letter long 3-letter words, you have 3 choices. You have A, B, and C. If you have 2-letter long 3-letter words, your first letter of those 2 can be each of the 3 letters possible, A, B, or C. And the second one can also be each of the 3 letters possible. So in total, you have 3 for the first, 3 for the second. You'd have to multiply them together, so you have 9 possible combinations. Let's say you have 10 letters long, or 10 character long answer in a language with 3 characters. Each of those 10 spots could be one of 3 characters, so that would be 3 to the 10th possibilities. So that's kind of important to know to solve this problem. And then the other thing to point out is that the number of clarification requests that Norbert has to answer can be enormous. Obviously, since there are 10 to the 11th clarification requests, we can't actually count each clarification request and figure out what each answer is. We just have to figure out how many characters he'll use total. So we can do that by just figuring out how many of a certain length long of response would he need, and then how many characters would he use typing out that many of that length response. Alright, so we'll get into programming this, and this is where things do get a bit challenging. So bear with me if I make a mistake here, because I'm doing it live. Oh, interesting. Alright, we don't need that. That's what we're doing now. I must have started this last night. Alright. Then we want our main and a scanner. Eclipse has to load again. Alright, and then first thing we're given is requests to answer. And then the next thing is letters in his language. Okay. So the way I'm going to go about solving this is count down the request to answer. So we're going to start with that many, and then we're going to subtract from that number once we've answered them. So once that's 0, then we're done. So we want to say, while requests to answer is greater than 0, we want to keep answering requests. We're also going to need, oh, this is a long, I'm sorry, right, because we have over 10 to the 9th possibilities. Alright, so we're also going to need a long total characters, because we're going to count how many characters we type, and then at the end we're going to want to print that. And then we're also going to want to keep track of how many characters in the current response. So that's going to be, that can be an int. And we're going to start answering all of the 1-character responses, and then we're going to move on to 2. So because of that, because you always, each turn you want to use the fewest characters per response you can, that would make this a greedy problem. So this is the greedy problem of the set. A lot of them can be greedy depending on how you look at it, but this is most easily solved in a greedy way, I would say. So we are going to, first we want to add to our total characters, and then we're also going to want to, let's equals something. We're going to figure that out. So we're going to answer some number of requests. The number of characters we're going to type is that number times the number of characters per request. And then after we do that, total characters. Okay. So that's how many characters we'll use answering the requests like this. And then after we do that, we're going to want to subtract from requests to answer. And then for the next time, we're going to want to increment the number of characters in our language, or sorry, not characters in our response. So the first time we go through this while loop, we'll be doing 1-character responses. The next time, we'll worry about 2-character responses and 3-character responses, etc. So we have to figure out how many requests we're going to answer, and then based on how many requests we're going to answer, we'll add that many characters to the number of characters we've typed, and then we'll subtract that number from, no, this is requests to answer, my bad, from the number of requests we have left to go. So this right here, we can find pretty quickly. We want to answer, well, okay, so if the number of possible 3-letter words, if we get to 3-letter words, for example, if the number of possible 3-letter words is greater than the number of requests left, we only want to answer however many are left. We don't want to answer more than we have to. So we want to do the math.min of requests to answer, and the minimum of that and however many responses there are. So that's actually the math.how, and it is the characters in language. So if you have 3-character words, it's 3 because each spot has 3 possibilities, and the number of spots there are the characters in response. So if you're given 10-letter words, for example, then there are 10 different spots that you have to fill. And yeah, we need to cast it along because that's a double. So we shouldn't lose significance there, I don't think. But, okay, so if you have 3 spots, or 10 spots, sorry, if you have 10 spots, each spot can be one of 3 different things, then your total number of permutation, total possibilities are 3 to the 10th. So that's how we figure that out. And then if we have fewer requests left to answer than that, then we'll just answer however many we've left, and then we'll do things from there on. Alright, so let's see if we've made any glaring mistakes so far. Things don't look too bad, but they might be. So here's our sample input, and that's the sample output we're expecting. So that is the negligence problem. This was problem 5 in the BCPC 2017 set. And congratulations if you were able to get it. If you weren't, this was the kind of the mathematical trick behind it. This relied on efficient counting and kind of a greedy algorithm, whereas 1 was more of a number of properties algorithm, prime number of properties. So this was the intended way to do it. There may have been other ways to do it. And one last thing to go over is that this solution solves it in log base, what is the log base q? Sorry, log base n of q. and counting each solution would be just O of Q. So because this solves it in log n time, or log Q time, that's something that's easily solvable for huge numbers, because like the log of 10 to the 11th is somewhere around 30 or something tiny, whereas this is enormous. So you save a ton of time there, which allows this approach to work. So thank you for watching, and good luck with the rest of the problems, or good luck with your own implementation of this.